Number 17 here is another differential equation they want us to solve, and we're going to have to separate our variables here. What's unique about this problem and a few of the other problems around it is that it's got a plus or a minus in the middle of it, and usually we prefer differential equations not to be polynomial expressions with multiple terms. So that's kind of our clue here, that the first move I'm going to make is take this whole term here and just bring it over to the right-hand side. So I'm going to end up then with dy dt is equal to, and then we've got a positive now, 20t to the fourth e to the negative y. So now it's just down to one term on the left and one term on the right. And that actually means we can move things around a little bit more freely in terms of multiplication or division to separate our variables. So we want to get all the y's on the left-hand side, including the dy, and all the t's and the dt on the right. So what we're going to do here is we're going to multiply both sides by a dt, and also I want to divide by this e to the negative y. So I'm going to write here times dt and divided by e to the negative y. And I'll go ahead and do that, of course, on the left side as well. So what's going to happen there? The dt's are going to cancel on the left. The e to the negative y's will cancel on the right. And so my left side now, you'll notice, though, I'm not going to write that as 1 over e to the negative y. It's just kind of silly to put a negative exponent on the bottom of a fraction. I would just move that up to the top now and say, oh, okay, that is e to the positive y, which is going to be much easier for us to deal with anyway. So e to the negative y dy is going to equal then a 20t to the fourth dt at the end of all that. So now we've got everything separated, so we'll go ahead and anti-differentiate both sides of this equation. Antiderivative of e to the y is just e to the y divided by the derivative of the exponent, but that's just 1 here. Equals, looks like we're going to have a 4t to the fifth power and a plus c at the end of all that. And if I'm remembering this right, I think this was just a general differential equation, not one with an initial value here. Yeah, we're just looking for a general solution, so it's okay to leave that plus c there. And all we have to do now before we're done here, guys, is to get rid of the e, which we will do by taking a natural log of both the left and the right, and the natural log of e to the y on the left is going to give us just a y there, and then we've got the natural log of 4t to the fifth plus c. Notice I'm keeping that plus c inside the parentheses, and what is tempting that a lot of people want to do is distribute this natural log in here and say, okay, that equals a natural log of 4t to the fifth plus the natural log of c. Guys, we cannot do that. You cannot distribute a logarithm as if it were some type of numerical value here. You can distribute a constant, you can distribute a variable, but we can't distribute an operation like log or sine or cosine or anything like that. So I think that's about as good as it's going to get, and that's our answer then for problem number 17.